Now let's look at some exceptions to the octet rule for Lewis structures. Sometimes we're going to wind up not having enough electrons. Sometimes we're going to have more than an octet of electrons. And so if you haven't read the introductory material in the box, please pause the video and do so. The first one we're going to look at is IF2 that has a -1 charge. Iodine is in group 7. Fluorine is in group 7. 2 fluorines, 1 iodine, 21 electrons from our atoms, valence electrons. -1 charge, and these means we need to add an electron. We need to have 22 electrons. So the central atom is going to be, keeping symmetry in mind, the iodine. So, to that, we've drawn 2 bonds. That's 4 electrons. We have 18 left to draw. How many electrons does each atom need to finish an octet? Each fluorine has made 1 bond, has 2 electrons, needs 6 more. The iodine has made 2 bonds, that's 4 electrons, it needs 4 more. So 6 and 4 is 10 and 6 is 16. And we have 2 electrons left over. So we're going to wind up having what's called an expanded octet. And where those electrons go is on the central atom. So let's give the fluorines the 6 they need. And then the iodine gets the 4 that it needs. But now we've only drawn in 20 electrons. We've got to have 22. And those last electrons go on the iodine. The reason iodine can do that is because it now has d electrons that are available to it. So iodine is in the 5p block, and so it certainly has d orbitals available to it, and they can use those d orbitals with which to hold these extra electrons. And we need to make sure that we put brackets around that and the -1 charge. The other way to go about doing this problem is iodine in the middle, 2 fluorines. That gives us our 18 electrons that back here that we have left to draw in. So 2, 4, 6, 8, 10, 12, 14, 16. That wound up giving everything an octet. We still had 2 more left over, so that goes on the iodine. SF6, sulfur hexafluoride. Sulfur group 6, fluorine group 7. I got 6 of those. So 6 valence electrons from the sulfur. 7 6s are 42 electrons for the fluorine. That gives me 48 electrons in all. The central atom is going to be, in keeping symmetry in mind, it's going to be the one that we only have 1 of. So we're going to have 6 fluorines around this sulfur. So right now we've already busted the octet rule. That sulfur has made 6 bonds with 12 electrons. It's got more than an octet. But that's going to have to be what it is. We got to bond everything. That means we got 36 electrons left to draw. If we look at each fluorine is made a single bond. That's 2 electrons. You need 6 more to finish an octet. So 6 times 6 is 36. We just got the exact right number. So if we put in 6 electrons around each fluorine, that will give us the correct Lewis structure, sulfur hexafluoride. Xenon tetrafluoride. Here's an example of a noble gas making a compound. Don't make many compounds, but we can beat on them and make them do that. So xenon, group 8. 8 valence electrons. Fluorine, group 7. That means we got 36 valence electrons. The central atom will be xenon, to which will bond 4 fluorine atoms. That means we've drawn in 4 bonds, that's 8 electrons. We've got 28 electrons left to draw. Each fluorine has made 1 bond. It needs 6 more electrons to finish an octet. That's true for all 4 fluorines. If we draw those 4 fluorines in, for those 24 electrons to the 4 fluorines, we'll have 4 electrons left over. So let's draw in the 6 around each fluorine. And now where are we going to put those 4 extra electrons? We're going to put those on the xenon. The extra electrons always go on the central atom. So that's a correct Lewis structure for xenon tetrafluoride. BH3, boron trihydride, or borane. Borane, group 3. Hydrogen has its just 1 electron, but we got 3 of them. That gives us 6 electrons to put in our Lewis structure. No more, no less. The central atom, keeping symmetry in mind, will be boron. And it really doesn't matter in terms of a Lewis structure anyway, whether we draw them at 90 degrees, 120 degrees, or whatever. So we've drawn in 3 bonds, each worth 2 electrons, 6 electrons. We don't have any left to draw. We can't put any more electrons. We only got 6. And so this molecule will wind up being electron deficient. It's just got the 3 single bonds for BH3.